Evaluating Formative Measurement Model, Step 3, Indicator Weights. In the last session, we assessed collinearity. In this session, we are going to assess indicator weights. Now, this is the last step in evaluating formative measurement model. Now, if you've got a formative construct in your study, you've got to have 3 steps performed. Number 1, you assess the convergent validity. Number 2, you assess formative measurement models for collinearity issues. And number 3, you assess the significance of relevance of formative indicators, that is your indicator's weight. Let's start with step 3. Next, analyze the indicator weights for their significance and relevance. Consider the significance of the indicator weights. Now, how do we assess the significance? Again, we will have to run our bootstrap procedure. Now, to run the bootstrapping procedure, we will use bootstrap_model function. And in the bootstrap model, we will have SEMinR model. Now, this is the first parameter that allows specifying the model on which we apply bootstrapping. The second is your bootstrap samples. Normally, it's recommended to have 10,000. Now, since using great number of samples requires much computational time, you may choose a smaller sample, 1000, for initial model estimation. For final result reporting, it is recommended to have 10,000. For final result reporting, however, it is recommended to have the sample of 10,000, that is 10,000 bootstrap samples. Now, there is another important property called the cores. Now, recommended is using this option because it makes bootstrapping much faster. As you might not know the number of cores in your device, recommended is using parallel detect cores function to automatically detect the number of cores and use the maximum cores available. By default, cores will be set to maximum value, and as such, if you do not specify this parameter, your bootstrap will default to using maximum computing power of your CPU. Now finally, the seed allows reproducing the results of a specific bootstrap run while maintaining a random nature of the process. Now, however, this may get a bit too technical for a normal management sciences student or social sciences student. I recommend keeping it to default. Now, instead of 1000, just change it to 10,000 when you are doing your final analysis after all what you have done with the trial runs or assessing the preliminary output. Now, how do we do this? Just simply copy this text here. And this is the text we've already done in the previous sessions with regards to evaluating our formative model. Now, let's run this. Now, look at this. There is an error. Now, let's see what the error is. The reason being, after the previous video, I did close this particular software. Now, since I closed it, everything got closed. There is no library enabled or loaded. So what you need to do is, obviously, I need to rerun this whole text again. Now look at this. Bootstrapping model using SEMinR. SEMinR model successfully bootstrap. Now again, the point of telling you all these errors is that obviously you will encounter some of them. So you should know what the error means. Now that we have done the bootstrapping, now we need to assign our bootstrap output to this summary boot object. Now how do we do this? Again, we will call this summary function and we will put in all the output from bootstrap into this particular bootstrap object. How to do this? We've already done this, but we are going to use another parameter, that is alpha parameter. The alpha parameter allows selecting the significance level. So what is your significance level? In this case, we are going to use the default. The default is 0.05 for two-tail testing. When testing indicator weights, we follow the general convention and apply two-tail testing, that is at 5%. Now, how do we do this? Look at this alpha level here. Now again, look at this. Previously, when we were doing summary, we were just having this boot_model that we ran earlier. But now we are going to add this argument as well. Now let's see how we do this. Again, we simply need to copy this text here. Now that we have run our bootstrap model, we need to get the summary of this boot model. How do you get the summary? Again, call in the summary function, provide it the arguments. One of them is your bootstrapped model, the other is your alpha value, and this returns the summary which is stored in this object, and then we can call the sub objects as we want to. Now in this case I'm interested in weights, so I'm going to call this. Now I'm going to select this, I'm going to run, and here is your output. These are your indicator weights. Now how do we interpret this? The third step in assessing formatively measured construct is examining the statistical significance and relevance, that is size of the indicator weights. So by relevance we mean size, and then statistical significance is assessed using t-value or bias corrected confidence interval. The indicator weights result from regressing each of the formatively measured construct on its associated indicator, because the arrow is flowing from the indicators to the construct. As such, they represent each indicator's relative importance for forming the construct, because those indicators are actually forming the construct. That is why it's called formative model. Now significance testing of the indicator weights relies on bootstrapping procedure as we just ran, and it will yield t-values. Again, assuming that our level of significance is 5%, if your level of significance is 5%, the t-value above 1.96 will suggest a significant indicator weight, that is for two-tailed test. However, these critical values for significance levels of 1% and 10% probability error are 2.576 and 1.645 for two-tailed. Now if you take your significance level at 1%, your t-value will be this, so anything above this will be significant. Now if you take your significance level at 1%, now this is the t-value, so anything above this will be significant. Now if it's taken at 10%, this is the value, this is the t-value, so anything above this will be significant. Now in this case we are taking it at 5%, so anything above this will be significant. So look at this, this is your output, and you got this output by calling in this sub object of summary underscore boot object. Now look at this, the t-values. Now this is insignificant, and look at this value, the original estimation, the relevance or the size of the weight is not that good. Look at this, significant, significant, significant. Well, you can say to a certain extent it is closer, but still let's keep it 1.96, insignificant, insignificant. Now some of them are significant while some of them are insignificant. Note that the bootstrapped values are generally for all the measurement model weights, but we only consider the indicators of formative construct. Now look at this. This was reflective, but still you got it in the output, but we are not going to discuss this. We are only interested in the formative constructs. Now let's recall. For 1% it was 2.576, that is your t-value. For 5%, for 10%. But in this case we are focusing on 5%, 1.96. Some of the weights are significant while others are insignificant. However, majority of them are significant. So what should we do now? Shall we delete these indicators? No. There are other statistics to evaluate now. Confidence intervals are an alternative way to test the significance of indicator weights. They represent the range within which the population parameter will fall, assuming a certain level of significance. If a confidence interval does not include a zero, the weight can be considered significant and the indicator can be retained. However, on the contrary, if the confidence interval of an indicator weight includes a zero, this indicates the weight is not statistically significant, assuming the given significance level, that is 5%. In such a situation, the indicator should be considered for removal from the measurement model. However, we will further look into other statistics as well. If an indicator weight is not significant, that is your t-value is low and there is a zero in the confidence interval, it does not necessarily interpret it as evidence of poor measurement model quality. Now you should actually look into the absolute contribution of the formative indicator. How do you look into the absolute contribution? You have to go in and assess the formative indicator's loading. I'm going to tell you how to do this. But first, let's look at the confidence interval. And again, your loadings should be greater than 0.50. And higher suggests that, obviously if it's 0.5 or higher, this suggests that there is an absolute contribution of that indicator in forming the construct, and we should retain it. Now let's look at this. Again, this was insignificant. Is there a 0 in between? Well, yes. This is minus, this is plus. So there is a 0 in between this minus 0.119 and positive 0.327. There is no 0 in between. Both of them are positive, so there is no 0. The 0 does not fall in between these two values, 2.5% confidence interval and 97.5% confidence interval. Now if one value is negative, the other is positive, yes, then there is a 0 in between. But otherwise, there is no 0 in between. Now look at this. 1, 2, 3, 4, 5, 6, 7. Now we've got 7 indicators, that is, they have insignificant indicator weights. Now again, this is the same thing, that it does not include a 0, so obviously it is significant. Now if it does include a 0, then obviously there is an insignificant impact of these formative indicators on the construct. Moving on. Now if the weights are insignificant, or even if they are not insignificant, you will have to assess the indicator's loading. But this becomes important if these are insignificant. So let's look at this. Vision 1, Dev 1, Dev 2, Dev 3. Let's look at few of them. To assess the indicator's absolute importance, we examine indicators loading. Now, where are these loadings? Again, let's go back to our summary object. Let's copy this. Now what is this? Summary underscore boot. This object holds the summary from your bootstrapped results. Now bootstrap loading is the sub-object. Let's run it. Now let's have a look here. Vision 1, look at the loading, 0.863. Now this is well over 0.50. This should be retained. Look at this, Dev 1, 2, 3, well over 0.50. Now all of them here, look at this, all of them are over 0.50. Now let's assume, what if one of them here, let's say Vision 1 was 0.463. Then again, you should have looked into this value here. Is it significant? Yes, it's significant. There is no 0 in between. So, although your absolute contribution is low, but this indicator is significant. Now, you can retain the item because there is no 0 in between. Although the absolute importance is low, that is, let's consider this is 0.463, but it is significant. So, you can retain the item. Moving on. Now that we have assessed the loadings, look at this output. We have assessed the output as well. We retain all the indicators in the formatively measured construct, even though not every indicator weight is significant. Although the weight wasn't significant for Viz 1, Dev 1, Dev 2, Dev 3, but we still retain them. Why? Because the absolute contribution is high and they are significant as well. In the next session, we are going to focus on a summary of what we have done up till now. Shall we delete or not delete the formative indicators? Stay tuned. Thank you.